Hi friends, welcome to a MKS Tech Talks YouTube channel. So in our channel, we are planning a free DevOps training series. So by the end of this training, you will get advanced knowledge in the DevOps. So even if you don't have any basic knowledge, we are going to teach from basics. So here, these are the topics we are going to cover. The topics are we'll start the training with Linux basics. So Linux basics is the prerequisite to become the DevOps engineer. So due to this, by considering this, I'm going to start with Linux basics. And this Linux basics, we will have around 7 to 8 classes. So once we done with the Linux basics, then we'll cover the required DevOps training tools like Git, Jenkins, Docker, Kubernetes, Ansible, Terraform. Then once we complete all these tools, then we'll start AWS Cloud, Amazon Web Services Cloud. So along with these DevOps tools, we need any one of the cloud platform. So we are going to cover AWS Cloud. Under AWS Cloud, we will cover around 8 to 9 services. So once we done with this training, we'll have interview question discussion and then resume preparation discussion. So here in this series, I'm going to upload weekly 3 to 4 videos continuously, and you will get around 55 to 60 total classes. So this is a very good opportunity for you to become a DevOps engineer. By the end of this course, you can crack any type of DevOps interviews. So to get all my updates, please subscribe to my YouTube channel, AMKS Tech Talks. So thank you. So as a DevOps engineer, what we are going to do is, so we are going to create a CI/CD pipelines. That is our main role. Okay. So creating CI/CD pipelines in different environments and maintaining these pipelines is our main role as a DevOps engineer. Okay. So here, first of all, what is a CI/CD means? CI/CD is nothing but continuous integration, continuous integration, and continuous deployment. So this is the full form of the CI/CD. Okay. So here, so while performing this, while creating these CI/CD pipelines, so we are going to use the different DevOps tools, like we are going to use Git and whatever the tools we discussed in the demo, right? So these tools we are going to use while creating these CI/CD pipelines. Okay, so Git, Jenkins, Docker, Kubernetes. Okay, so these tools we are going to use while creating our CI/CD pipelines. Okay, so here another definition we have for the CI/CD is similarly we can call this CI/CD as continuous integration and continuous delivery also. So this is the another definition we have for the CI/CD. A continuous deployment or continuous delivery. So sometimes we are calling as a continuous delivery, and sometimes we are calling as a continuous deployment, depending on the process we are following. Okay. So here, the purpose of this CI/CD pipelines is to automate the flow, the source code flow from development phase to deployment phase. Okay, so you know that most of the organizations nowadays are working on the Agile SDLC, right? Okay, so Agile is the SDLC most of the organizations implementing nowadays. Okay, so under Agile SDLC model, So we will have different phases, right? So we'll have whenever we are trying to start any project, we have to plan that project. Okay. So who is going to plan that project? There will be architects, right? So architects will provide the planning. And once we have the plan, then in the next phase, development team come into action. Okay. So a dev team will develop the code. Okay. So in the agile methodology, what is happening is we'll have different development teams. So depending on the feature, so one development team is going to work on one feature, another development team is going to work on another feature, like that. So we'll have different development teams who are working on different features. Okay. Here we'll have individual development team. So feature wise, development team will be available. Feature wise, dev team will be available, and they will work on their feature development. Okay. So this is what is going to happen in the next phase. So once we have code, then we are going to build the code. Okay. So once the code is ready, we are going to build the code. So build here, what we are doing, we are doing compilation, then we are doing we are validating the test cases. Okay. So test cases validation we are performing, then code quality checks we are doing. Okay. So quality checks we are doing, and if everything is fine, we are going to deploy. Okay. So these are the different phases we have in agile methodology, agile SDLC model. So now here in our agile SDLC model, so how we are creating this SDL and CICD pipelines is, so first of all, if we want to work on the code, okay, so what we have to do is, so we are going to maintain the source code from the different development teams. Okay. So we'll have a source code from the different development teams. So the code from these development teams we have to maintain. Okay. So in the agile methodology, so you know that we are going to work on the sprint basis, right? Okay. So we'll have at sprint one, we'll have one code. At sprint two, we'll have other code, different code will be available sprint wise. Okay. Now here, what we have to do is, while creating the pipeline, right? So, so in our CI/CD pipeline, the first phase will be getting the code from the source code management tool. Okay. So let me take this CI/CD pipeline. Okay. So how the CI/CD pipeline looks like is, in the first stage in our pipeline, the first stage will be getting the code from the development team, getting the different versions of the code from the development team. Okay. So how we are going to get this code? So what is happening here? So whenever there is a code ready at the end of every sprint, what our development team is doing, so our development team will push the code to the SCM. Okay. So code will be at the end of every sprint. Okay. So at the end of every sprint. So you know the sprint, right? A sprint is nothing but that is around 10 working days or 2 weeks, like that in most of the cases. Okay. So at the end of every sprint, dev team will push the code to SCM repository, source code management tool. Okay. So that is a version control system. we'll push the code to the version control system. Okay. So now where we will have the code, our code will be available under version control system. Okay. So our code will be available under version control system. Now here, once we have the code in our version control system, so what we have to do is we have to pull the code from the version control system. Okay, so the process of pulling the code from the version control system, we are calling as the checkout process. Okay, so in the CI/CD pipeline, the first stage will be the checkout process. Okay, so here now I'm calling the process as checkout. Now, in our case, we are going to use a Git and GitHub. So we are calling this first stage as Git checkout. Git checkout. Okay. So what is this Git checkout? Git checkout is nothing but the process of pulling the code from the SCM repository. Okay. So from SCM repository, so we are going to pull the code. This process we are calling as the Git checkout. Okay. So let us consider this is the SCM repository we have. Okay. So SCM is nothing but version control system like Git or GitHub. Okay. So from the version control system, so we are going to pull the code. We are going to pull the code. Okay. So this process we are calling as the Git checkout process. This is the first stage we have in our pipeline. Okay, so in our pipeline, the first stage is Git checkout. Git checkout is nothing but getting the code, pulling the code from the version control system. So to this version control system, how we are getting the code? To this version control system, how we are getting the code? So we are getting the code to the version control system from our developers. Okay, so from the developers, we are going to get the code. So here we'll have development team at the end of the every sprint, right? So our developers will push the code into the version control system. Okay, so they are going to push the code here. Okay, now this is the process going to happen in the real time. Okay, so how to pull the code from version control system? Now this version control system is like Git or GitHub. So this is like a GitHub. Okay, so we are going to work on the GitHub in our projects. Okay, this is like a GitHub. So from the GitHub, we are getting the code into our Jenkins server. Here you see, so we have Jenkins, right? We have Jenkins, right? So what is the purpose of Git here? So Git is to maintain the version, different versions of the code from the development team. Okay. Then we have Jenkins. What this Jenkins will do? So Jenkins will try to process the code once we have the code in our version control system, right? So this code will be processed with the help of the Jenkins. So to process the code, what this Git Jenkins will do is Jenkins will pull the code into the Jenkins server. Okay, Jenkins will pull the code from the version control system. So this process we are calling as the Git checkout. Okay, so once we do the Git checkout, where our code will be available? So our code will be available in the Jenkins server. Okay, so once we do the Git checkout, our code will be available in the Jenkins server. Okay, so now once we have code in the Jenkins server, so we can work onto the code. So means we can build the code. Okay. So once we have code in our Jenkins server, we can build the code. So build process involves all these things. Okay. So we can compile the code, we can validate the test cases, we can do the quality checks. Okay. So all these things we can do onto our code. Okay. So the next stages in our CI/CD pipeline is so compilation. Okay. So compile. We are going to compile the code and we are going to validate the test cases. So we'll validate the test cases. We are calling this process as testing. Okay. So testing. So this testing is like a unit case testing. Okay, so unit testing. Then quality checks. We are going to do the quality checks also. Code quality checks. Okay, so here these are the different stages we'll have in the CI/CD pipeline. So quality checks. Okay, and if everything is fine, so we are going to deploy the code. Okay, the final phase will be deployment of the code. Okay, so here the final stage will be like deployment. Okay, so these are the different stages we'll have in our CI/CD pipeline. So here, so first will be the git checkout. From the git checkout, we are going to compile, and then here, if compilation is success, we are going for testing, and after that we are doing the quality checks. Okay, and after that, if everything is fine, okay, so we are going for the deployment. Okay, so these are the different phases we have under CI/CD pipeline. So these are the different phases we'll have under CI/CD pipeline. Okay. Now, so in this process, we are going to use the different tools, our CI/CD tools we are using. Okay, the DevOps tools we are going to use. Okay, so for Git checkout, who is doing this Git checkout? Jenkins is doing this Git checkout. Jenkins will pull the code from the GitHub. Okay, and once the code is available, so we are ready to compile. Now, while doing the compilation here with the Jenkins, what is going to happen is, so this Jenkins cannot perform any activity directly. And that is the problem with the Jenkins we have. Okay, so Jenkins cannot perform any activity directly. So what this Jenkins will do is, Jenkins will take help of other tools like, so Maven. Okay, so Maven is a build automation tool. Okay, so if our code is a Java code, we are going to use Maven as the build automation tool. So what this Maven will do is, so what are the operations we mentioned here, right? So compilation, testing. Okay, so these operations, Maven is going to do. Okay, compilation, testing, packaging. Okay, so these things Maven is going to do. Okay, so here, so this Maven will do. So it will perform compilation. Okay, it will validate the test cases validation. Okay, and packaging operations. So these operations will be performed by the Maven. Okay, so Maven is a third party tool. So what this Jenkins will do is, Jenkins directly will not perform these operations: compilation, test case validation, packaging. These operations Jenkins will not perform directly. So what this Jenkins will do is, Jenkins will trigger the Maven. Means, so there will be one more tool we'll have, that is known as a Maven. So Maven is going to perform these operations. Okay, so Maven is going to perform these operations like so compilation. Okay, so testing and packaging. So like these operations will be performed by the Maven. What this Jenkins will do? Jenkins just trigger the Maven. Okay, so whenever Jenkins triggers the Maven, so Maven will compile the code. Maven will validate the test cases, and similarly we'll have one more phase like packaging. packaging. Okay, so packaging also done by the Maven only. Okay, similarly, so to do the quality checks, code quality checks, so this operation also Maven will not perform, the Jenkins will not perform directly. Okay, so for quality checks, for doing the code quality checks, okay, so what this Jenkins will do is Jenkins is going to use one more third-party tool. So one of the popular tool for quality checks is SonarQube. Okay, so SonarQube is one of the popular code quality check tool. To do the quality checks, we are going to use a SonarQube. Okay, so it will perform code quality checks. Okay, so what this Jenkins is going to do? Jenkins is going to trigger the SonarQube, and SonarQube will perform these quality checks. Okay, so this quality checks will be performed by the SonarQube. Okay, and here this with the help of the SonarQube, we can achieve this operation. Okay, so SonarQube we are going to use. Okay. So like this, we are going to cover all these tools also in our course. So we are going to work on Maven. Okay. So what is Maven? How Maven is going to work? How the Maven will perform compilation, testing, all these operations. These things also we are going to cover, and we are going to cover about the SonarQube also. Okay. Now, so here, if everything is fine, so compilation is success, and we validated test cases and quality checks passed. Okay, if we passed quality checks, if everything is fine, so there will be packaging operation. Okay, so here we'll have the next stage. Here will be quality checks. After that, we will have packaging. Okay, so this packaging also done by the packaging will be also be done by the Maven only. Okay, so what this Maven will do is under packaging stage. So Maven will here. So Maven will generate artifacts. Maven will generate artifacts. Okay, so artifacts are nothing but that is jar files. Okay, jarware files, archived files, Java archived files. Okay, web archive files. So these files we are calling as the artifacts. So if everything is success, means if the build is success, what we are going to get? So if the build is success, we are going to get the artifacts. Okay, so here in this case, if build is success, then we'll get the artifacts from the packaging operation. Okay, so these artifacts we are going to deploy. We are going to deploy into the deployment server. So here we have deployment phase, right? Okay, so we are going to get the artifacts here, and these artifacts we are going to deploy into the deployment servers. Now, so here we are getting the artifacts, right? So in this stage, we are getting the artifacts. Okay, we are getting the artifacts. So these artifacts we are going to deploy into the deployment servers. Now, so in the real time, what is going to happen is from our development team, right? So we already know at the end of every sprint, we are going to get a different version of the code. Okay, so at the end of a sprint one, we'll get version one. Okay, so we'll get version one at the end of sprint one, and we'll get version two at the end of sprint 2, like that different versions of the code we are going to get from our development team. Okay, so here for version 1, let us consider. So now I pushed version 1 code into my GitHub. Okay, so the version 1 code will be pulled by our Jenkins. Okay, so here I got version 1 code, let us consider. Okay, I got version 1 code into my version control system. The same version 1 code will be pulled into our Jenkins. Jenkins is going to pull the version 1 code. Okay, so we'll get version 1 code. Okay, so now So once we pulled version 1 code, so onto the version 1 code, these operations will be performed. The compilation, testing, quality checks, okay, packaging, these operations will be performed. And we are getting the artifacts, right? So let us consider for version 1, I'm getting artifact 1, artifact 1. Okay. So this artifact 1, I can deploy into my deployment server. Okay. If I deploy artifact 1, this version 1 related code will be available in the live environment. Okay, so whenever we deploy these artifacts, right, the respective code changes will be available. Okay, so in our application, okay, the respective code changes will be reflected in our application. Okay, so for version 1 code, we got artifact 1. Okay, for version 1 code, so just observe here. So for version 1 code, okay, so we got artifact 1. For version 1 code, we got artifact 1. So similarly, if we deploy version 2 code, okay, so so let us consider. So now we are at the end of sprint 2. Okay, at the end of the sprint 2, so version 2 code will be pushed here into our version control system. Now, so let us consider we pushed version 2 code, okay, into our version control system. Version 2 code we pushed. Okay, so this version 2 code will be pulled by our CICD tool like Jenkins. So what this Jenkins will do? So it will pull version 2. Okay, now onto version 2 code, these build operations will be happen. Okay, so our Jenkins is going to compile, test, and it will package the code. Okay, so finally what we are going to get? So we are going to get artifact to for version 2 code. Okay, so like that, whenever there is a change in the version of the source code, the artifact version is also going to change. Okay, so to maintain all these artifacts, so we are going to use one artifactory tool. There will be one artifactory tool. Okay, so what this artifactory tool will do? So this artifactory tool will maintain all the artifacts. Okay, so at the end of for every release we will get one artifact. Okay, for every release we'll get one artifact. So all these artifacts will be maintained by the artifactory tool, like we have. So we have artifactory tools like we have JFrag or Nexus. Okay, so like that we have different artifactory tools. So by using these artifactory tools, so we are going to maintain all the versions of the artifacts. Okay, so now, so whatever the version of the artifact we need, we can deploy that particular version into our deployment servers. Okay, so this is what going to happen in the real time. So this is how we are going to create the CI/CD pipelines. Okay, so in this way we will create the CI/CD pipelines. Now this total process we are calling as the CI/CD pipeline. So what is the meaning of CI/CD is? So continuous integration and continuous deployment. Okay, continuous integration and continuous deployment. So what is continuous integration is? So continuous integration is nothing but the continuous process of the development of the code, continuous process of the testing of the code, and whenever we found any bugs, okay, whenever we face any bugs under testing phase, that bugs information will be given to the development team. Again, the development team will work to fix these bugs, okay, and the respective code will be pushed to the version control system. Okay, and this is the continuous process. Okay, this is the continuous process. So this process we are calling as the continuous integration. What is the continuous integration? So here if you see, so our development team will develop the code, right? Okay, so different versions of the code we are going to get from the development team, and the same versions will be pushed to the version control system. Okay, and these versions will be pulled by the Jenkins server, and Jenkins will do the operations onto the code. Okay, so while performing the operations onto the code, so if we found any bugs, okay, if we found any bugs under testing phase, okay, so let us consider there is a bug. We got one bug here. Okay, so here if we got any bugs here, right? Okay, so that bugs information will be given to the development team. Okay, so let us consider here we found some bugs. We found some bugs. So who is going to do this bug fix? Who is going to do this bug fix? The bug fix will be done by the development team only. Okay, so this bugs information will be given to the development team. Okay, so this bugs information will be given to the development team. So what this development team has to do? So this development team has to again modify the existing code. How the bug fix will done? So due to the existing code, we are getting these bugs, right? So this development team will modify the existing code, and modified code they are going to push. Okay, the modified code, okay, the modified code for this bug fix, right? The modified code they are going to push. Okay, so the modified code they will push to the version control system, and from the version control system we will pull the code. The modified code will be pulled, and this code will be processed, means compilation testing will be done on the modified code. Okay, and again if we have any bugs, that bugs information will be again given to the development team. So again the development team will work on the bugs. So this is a continuous process. Okay, so this is a continuous process. This process is a continuous process. What is the continuous process here? So continuous development of the code by the developers. Okay, continuous compilation of the code, continuous testing of the code. Okay, continuous quality checks. Okay, so this is the continuous process. This process we are calling as the continuous integration. Okay, so any doubts up to here?
No, Chef. No, it's clear.
Okay, so now, so if everything is fine, we are going to get the artifacts. Okay, if a continuous integration process is success, when we are going to get the artifacts, we will get the artifacts if this continuous integration process is success. Okay, in the continuous integration process success, then we'll get the artifacts. So all the artifacts we are going to maintain under artifactory tools like JFrog and Nexus. Now, so let us consider I have 5 artifacts: artifact 1, artifact 2, artifacts like that. Okay, so if I am going to deploy each and every artifact into my deployment servers, okay, so means I am going to deploy artifact 1. Okay, I will deploy artifact 2, and I will deploy artifact 3, whatever I have in my artifact ring. All the artifacts I'm going to deploy into my artifact, into my deployment servers. So that process we are calling as the continuous deployment. Okay, so continuous deployment is nothing but the deployment of each and every artifact into our deployment servers. Okay, so but in some critical applications like banking sector applications, so it is not recommended to deploy each and every artifacts. Okay, so if I have some 10 artifacts, so I cannot deploy all the 10 artifacts into my deployment servers, into my production, let us consider. Okay, so I cannot deploy all my 10 artifacts into my production, because so I don't know which artifact is going to affect how. Okay, so what will be the effect of each artifact to my application? Okay, so if there is any mismatch, as if the artifact deployment is not as per the requirement, then it will affect my business. Okay, so by considering this, what is going to happen is, so once the CI process is success, once this CI process, continuous integration process is success, okay, so to deploy the artifacts, before deployment of the artifacts, so there will be one delivery lead. Okay, so there will be one delivery lead available. Okay, so this delivery lead is going to decide which artifacts we have to deploy into the deployment servers. Okay, so there will be delivery lead. So
So
this
sorry,
delivery lead.
I have one
Yes,
query. Sorry, I joined
yes.
late. I have one query. What is artifacts?
Yeah, artifacts are nothing but uh, jar or WAR files, archived files. So for
Okay,
yeah, these are files are ready for the deployment. Just this is the one form of files which are ready for the deployment.
got it, got it, got it. Just one more thing, like as I'm from testing field, so what happens
Yes,
in our over here are like the as you said that the first the codes are sent to the Git checkout and then it's sent for the compilation and then for the testing. Okay.
yes, yes.
So, but in our place, what happens is there's a testing environment and there's a production
Yeah,
environment.
yeah. 1 minute. So
So,
here,
so
that's why I told this testing is not belongs to QA environment testing. This is like a unit
okay,
testing. So
okay,
like these pipelines will have in every environment. So we'll have same pipeline in development environment. We'll have same type of pipeline in QA environment. We'll have same type of pipeline in production environment also. Okay. So in QA, whatever the testing happens, that is different from this testing. Okay, so and in this pipeline, this testing, so mostly we are calling is a unit testing. Okay, so
okay,
what is happening here is development team will write some unit test cases. Okay, so just we are going to validate the test cases through the code only. Okay, if the validation is success, then only this testing will be succeeded. Otherwise, this testing will fail.
okay,
Okay,
so got it. Yeah.
okay, so here there will be a delivery lead. So this delivery lead is going to decide which artifacts we have to deploy into the deployment servers. Okay, so means there will be manual intervention after the CI process. So up to this, we are calling it the CI process. So here, so up to this, we are calling as the CI process. CI process. Okay. After the CI process, there will be delivery lead. So there will be manual intervention in critical applications. Okay. So the delivery lead is going to decide which artifacts we are going to deploy into the deployment servers. Okay. So means if we have 10 artifacts, all the 10 artifacts are not going to be deployed. Okay. Only few artifacts will be deployed. Okay. So this type of deployment we are calling as the continuous delivery. So that is a difference between these two terms. Okay. So we already this is the definition, right? We have given a continuous integration and continuous delivery. Okay. Continuous integration and continuous deployment. Both we can this CI/CD term will be considered in both the ways. Okay. So continuous delivery we can consider, continuous deployment also we can consider. Only there is a process change. Only there is a process change. Okay. In the case of the delivery, so there will be a delivery lead. So there will be manual intervention after the CA process. Manual intervention after CI process. Whereas in the case of continuous deployment, no manual intervention. So no manual intervention will be available after a CI process. No manual intervention here. Okay. So as there is no manual intervention in the continuous deployment, so we can automate the complete pipeline from development to deployment. Okay. So as there is no manual intervention, okay. So total CI/CD, total CI/CD pipeline will be automated. Total CI/CD pipeline will be automated here. Whereas in the case of delivery, right? Okay. So we cannot automate the complete pipeline because as there is a manual intervention, so only CI process will be automated. Up to continuous integration only, we can automate the process. After continuous integration, we have to do manual work. Okay, only CI process will be automated. Okay. So this is how we are going to create CI/CD pipelines in the real time. Okay, this is the main work as a DevOps engineer. What we have to do is we have to design. We have to create like these pipelines in every environment. Okay, so we have like these pipelines in dev environment. Okay, so what is going to happen in the dev environment if we have like these pipelines? So we are going to automate this process. Okay, so here we have development team, right? So whenever there is a push happen, code change happen from the development team to the version control system. Okay, so automatically our Jenkins will identify that change. Okay, so what this Jenkins will do is, so whenever there is a code change, so automatically Jenkins will identify the code change, and automatically it will build the process. It will build the code. No, here no manual intervention is required to for this. What is the advantage with this CI/CD pipelines is no manual intervention is required. Once we design the pipeline, so everything will be automated here. Okay, so only the thing we have to do is, so we have to get the code from the development team. Okay, so once we got the code from the development team, so this Jenkins will identify the change and it will pull the code and it will compile the code. It will do the testing. It will do the quality checks. It will do the packaging, and finally the code will be deployed. So this is how our CI/CD pipeline will be automated. Okay, so as a DevOps engineer, we have to design like these pipelines, and so whenever there is a build failure, so we have to investigate what is the reason for the build failure. Okay, so all these things we have to take it as a DevOps engineer. So like these pipelines we will have in all the environments. Okay, so depending on the project, we'll have different number of pipelines. So in some projects we'll have for the same development environment, right? We can maintain 4 or 5 pipelines also, okay, depending on the size of the project. Okay. Thank you for watching this video. Uh, for more videos, please subscribe to my YouTube channel, MGS Tech Talks. Please like and share this video. Thank you.